Hello. In this video, I'm going to briefly discuss the differences between the older ramp wall standard detailing and a newer version of the ramp wall standard detailing for context, and we'll discuss when to use this, what is different about it, and I'll finally wrap up with some more standard in-country practices. So you all may be familiar, and if you're not, to this point in the course, you have heard about the standard details, and you know that the standard details originally came from Bridges to Prosperity. Now, the 3G standard detail, what I have here on the left, is that normal standard detail that we've been using for years. The 3G standing for 3 tiers, and this XX here meaning that it can be for any span or any ground profile condition. Now, this practice is still currently being used in Eswatini. We are piloting a new ramp wall method there, but for of the current date of the fall of 2022, we are still using this standard detail, this 3G standard detail ramp walls in Eswatini. Now, you can see our normal elevation view, and then in plan, what is of note is this 10 centimeter overhang of the bottom 70 centimeter thick wall. And if we move down into the section view, we can see that there's a standard 20 centimeter difference, step down between each ramp wall size, and we have our 30, our 50, and our 70 centimeter thick walls. Now, I won't go into detail here. We go into detail in the advanced course about how we actually analyze these walls, because they serve both as a formwork for the interior fill, they serve as a weight against the abutment sliding, and they also serve as compression struts between the anchor and the foundation, as the anchor is pushing on the ramp walls and transferring force into the foundation. Those ramp walls are getting squeezed as compression struts. Now, this is the previous standard design, and like I mentioned, what is still used in Eswatini and all of our other program countries. Now, what I want to mention that is different is what is happening in Bolivia. In Bolivia, due to the rock size and the masonry practices, we've developed a new detail, a new standard detail, and that is prefixed with that BO, standing obviously for Bolivia, and the ramp walls are a little bit different. So you can see this 3G example abutment, everything in elevation is exactly the same, but when we scroll into the plan, we see that the ramp wall is now flush with the foundation, and the ramp wall is line up flush with the tiers. And how does this actually happen? Well, if we go into our elevation view, we see that the 70 centimeter wall has actually been moved in 10 centimeters. So on either side, so our interior dimension is 2.2 meters or 220 centimeters. This is still a 70 centimeter wall, but we've increased by 10 centimeters the size of our walls above to reflect more what's happening in country and construction. So we now have a 40, 60, 70 centimeter wall configuration instead of the 30, 50, 70. And the final change is that we have two different distances here. 10 centimeters and 20 centimeters are those step distances. Everything else about the abutment is exactly the same. And then structurally, the implications are actually this becomes a more efficient structure, right? So if we remember from our analysis, the ramp fill is a density of about 1,900 kilograms per meters cubed, while masonry walls have a density of about 2,100 kilograms per meter cubed. So although we're not adding any material, we're actually subtracting material. If we look back in this plan view, we're subtracting total volume. We're adding more dense material into that volume. So although there might be slight negative implications for bearing, so we want to consider that in our analysis, there are going to be positive implications for sliding, right? Because the walls are less likely to slide because they are heavier and they're contributing more to sliding resistance. And the last thing I want to mention here on the note of in-country practices is that the level method, as described above, where we just take 1 meter down and across for 30, 50, 70, or 40, 60, 70, is going to be the most prevalent method in both Bolivia and Eswatini and should be used in your analysis.